Okay, this is 11.6, graphing square root functions. Okay, so when we have square roots in our function, so this is the parent graph y equals the square root of x, this picture right here. Okay, so when x is 1, y is 1, because the square root of 1 is 1. When x is 4, y is 2, because the square root of 4 is 2. When x, if we went all the way to 16, it would be at 4. Okay, so that's what it looks like. And then we can shift it from there, but there's no more to this graph because we can't have a negative under the radical. Okay, so if we had y equals, I don't know why it's doing the square root of x plus 2, then it would be the same, but it would start at 2 and it would go up. Okay, it would look just like this but go up. If it was the square root of x minus 1, then it would start down here at minus 1 and it would look the same. Okay, so that's kind of the shift there. Now, and we'll get into this in a minute, if it's the square root of x plus minus 2 underneath the radical, okay, that's going to start here and go. Okay, if it's underneath the radical, it actually goes the opposite. Square root of x minus 4, you would actually start at 4 here and go that way. Okay, so it goes, and if it was the square root of x plus 4, you would go over here to negative 4 and then go over. Okay, so those are just some shifts for you. And let me get rid of some of these things here. Whoops, I need that on there. Let me take these off. Okay, that's not what I want. That is what I want. And this. Okay, graph by making a table. So if we have y equals the square root of 2x, so that is different than the square root of x plus 2 or 2 plus x. Okay, remember this is just going to make it skinnier or fatter, just like it did on the parabolas. Okay, so we still need to make our chart like we did before. You only have to do a few of these. Okay, so we have our x and we have our y and we have our square root of 2x. Okay, and I would just do 0, 1, 2, because we can't have a negative under there. So if we have 0, well, the square root of 0 is 0. Okay, 2 times 1. Okay, now I would maybe, if you did 0, 1, and 2, it's fine. The square root of 2, is 1 point something, something, something. Okay, and then if you had the square root of 2 times 2, which is the square root of 4, which is actually 2. Okay, so we have 0, 0, and we have 1, and then 1 point something, so you would just go up a little bit. And then we have 2, 2. But we know it's going to end up kind of curving because that's just what the look, oh, my pen, the look looks like. Okay, so you would curve it like that. And then it says, what's the domain? So what you need to know is domain are your x values. So when you look at this graph, okay, what are my x values? So I don't have anything over here. I just have, let me change my pen. I go from here and I go, my x's get bigger this way. It goes along this curve, but that's my y's. Remember, y's are up here. Y's get bigger this way, but my x's will go forever, but they don't ever go negative. Okay, so you would say your x's are greater than or equal to 0. Okay, because you can have x equals 50 or 60 or 70, but you can't have x equals negative 1, negative 2, negative 3, things like that. Okay, now a few more where we are asking for the domain. So when it says to graph, you either need to make the table or you can just do it by its shifts. Okay, and I'll kind of explain the shifts here as well. So find the domain. So something like this is the parent graph where it was right there in the middle. Remember, it just went like this. Okay, so that's going to be x is greater than or equal to 0. So anything that looks like this, or it might have a 2 in front or something like that, that's not going to change the domain. Something that looks like this is going to move it up. I'm sorry, it's going to move it left 4 because it's inside. Okay, it's inside the radical, so it's going to move it left 4. So now my graph starts over here at negative 4. So my domain is x is greater than or equal to -4, and it goes the opposite. Okay, and I'm going to show you how to do this algebraically here in a minute. Okay, now x under the radical at -4 is actually going to be start here at +4. Okay, so x is greater than or equal to 4. Okay, and how you do it algebraically is you just put whatever's under the radical, the radicand, equal to 0. And then you add 4, x, and it's going to be greater than or equal to 0 because it's going positive. Okay, so here, okay, this graph, I'm just trying to kind of show you what the graph is going to look like. You're actually going to go left 4, but then you're going to go up 3. So this one right here makes it go left and right. This one makes it go up or down. And if it's under the radical or the radicand, it's the opposite. So this one's actually starting here and going. So my domain is starting at the 4. It's still just whatever's under the radicand that you put equal to 0. So it's still going to be x is greater than or equal to -4. Okay, same here. But the graph is going to look different because you're going to go left 4, but then you're going to go down 3. So it would look like this. This is going to help you with your shifts as well. Whoops. Okay, now it's not. Okay, there we go. It was a little late there. Okay, so again, if we set this equal to 0 down here, it's going to be x is greater than or equal to -4. Okay, now if you have one like this, so you're going to do 2x plus 5 equals 0. You set it equal to 0. We subtract 5. 2x equals -5. Divide by 2. Divide by 2. X is actually greater than or equal. It's always going to be that -5/2. Okay, because you're going to set whatever's under the radical equal to 0. Same with this one, because all this is going to do is shift it down 4. So all this did was shift it left 5/2, okay, which is the same as 2.5. All right, so over here, you're going to do the same. Your domain is x is greater than or equal to -5/2. Your graph would look like this. You're going to go over 4.5, 1, 2, 3, 4, and down 4. So it would be like this, and you would draw your graph, which I just drew. There we go. Okay, that is what this one would look like. Over here, if you wanted to know what this one over here would look like, okay, 1, 2, 3, 4.5. So it would just be here and over because it's not going up or down any. Okay, and that's really it. On this section, you just need to figure out how to do domain and figure out what the shifts are. So remember, if it's outside, okay, if it's added or subtracted on the outside, then it's going to move it left or right. Okay, I'm sorry, if it's on the outside, it's going to move it up or down. So let me actually get rid of that. So if we have y equals 2 square root x minus 4 plus 5. Okay, this isn't going to shift it. That's just going to make it skinny or fat. Same if you put something here. Okay, this is going to make it move opposite, left or right. Okay, and this is going to make it move up or down. Okay, so if it's positive, it's moving up. If this is negative, it's actually moving to the right because you're going to go opposite. Okay, that's it.